Hi everyone, this is a short video for filtering. Here we have an example here, FIR filter, finite impulse response filters. Xn is the input. Here z to the minus 1s are the delay elements or the memories of the filter, or in logic circuits we can say these are the D flip-flops. Here these are the coefficient H0, H1 and H2 are the coefficients of the filters. We have here three coefficients, therefore we can say this is a three-tap filter, and the outputs of the delay elements is the previous inputs. Okay, this is therefore xn minus 1, this is xn minus 2, and the output of yn is xn times h0 plus xn minus 1 times h1 and xn minus 2 times h2 is the output of the filter. But at the beginning it's quite different, because at the beginning we have xn but we don't have xn minus 1 and xn minus 2. Okay, and at the beginning when n equals 0 we have xn, which is x0 here, but xn minus 1 is x minus 1, we don't have this, and xn minus 2, this is x minus 2, we don't have this. Therefore we get x minus 1 and x minus 2 is 0 at the beginning. Therefore the output is only y0, the multiplication, the x0 and h0. At the second step, which is n is 1, in this time xn is x1 and xn minus 1 is x0. Yes, we have, this is the previous input, as you know, and xn minus 2 is x minus 1, we don't have this yet. The output y1 this time is x1. Here x1 we now, because it's the time for n1, x1 times h0, x0 times h1, x minus 2 is 0 here, and the output is this. For n equals 2, we have all these. Xn is x2, xn minus 1 is x1, and xn minus 2 is x0. We have all this. This time x2 times h0, x1 times h1, and x0 times h2. For n equals 3, this time x3 times h0, x2 times h1, and x1 times h2. And this goes like this. That's all. And for example, if we have an input like this 2 1 minus 1 1 and the h's are 1 1 1, let's see what are the outputs of the filter. Y0 is the 2 times 1, as you can see here, as you can see, x0 times h0 here, and the second output is this times x1 times h1 plus x0 times h1, and this time, as you can see here, this is 1 times 1, 2 times 1, the output is 3. And next step, minus 1 times 1, 1 times 1, 2 times 1. For the next steps, y3, we have this input right now. 1 times 1 minus 1 times 1 and 1 times 1. Okay, after n3 we can get some outputs here. y4, this times xn is 0, x4 is 0, 0 times 1, but inside we have memories and they have their own outputs. 1 times 1 and minus 1 times 1, the output is 0, and we have one more output here. 0 times 1, x5 is 0, x4 is 0, but x3 is 1. 1 times 1, here 1. These are the residual outputs. Okay, after n6, the output of the filter always be 0. Okay. In MATLAB, we have to write this code, x in square parentheses, h in square parentheses, 111. The convolution code is convxh. That's all. The output will be this. As you can see, here we have two more residual outputs here. Okay, sometimes we don't need to see these outputs. We have to write this code as this. Okay, same here in a double quote. Okay, we don't see the residual outputs. Okay, how many residual outputs will be depends on the number of the coefficients. Okay, here if we have 3 coefficients here, we have 2 residual. If we have 10 coefficients, we have 9 residual output. Okay, this is the end.